All right, so now let's consider a projectile that's launched from a 10-meter tall cliff. Let's make that 10.0. Yikes. All right, now let's consider a projectile that's being launched from a 10-meter tall cliff, 10.0 meters. And let's say the projectile is being launched at 9 meters per second at a 30-degree angle. It's just roughed in, so 9.00 meters per second at 30.0 degrees. Okay? And we want to know, the question will be, what is the time of flight? And what is the range of the projectile? In other words, how far away does it land? We're going to call this range. We can't use the range formula because that's only good if height 1 and height initial and height final are equal, and height initial and height final are not. So the first thing we need to do is determine the horizontal and vertical components of the original velocity. So the vertical component, being as it's opposite the 30-degree angle, will be 9 times sine 30, which is equal to 4.5 meters per second. And the adjacent side, adjacent to this 30-degree angle next to it, will be hypotenuse 9 times cosine 30, which is equal to 7.79 meters per second. Okay, and this is valuable because in calculating t, we need to use the change in height formula, 1/2 gt squared plus v initial t. This initial is vertical only. The vertical velocity only, which is this. Okay, we can't use 9 because 9 is not vertical, and only the vertical component contributes to the time. So rearranging this and putting in the quadratic formula, we can solve for time being 1.96 seconds. Now the next question is, what is the range or the distance, the horizontal distance that it lands as it goes in its path? What is this range? That can be found by using the simple formula. Velocity is distance over time only because the horizontal speed, and this is the horizontal displacement or horizontal distance, range, that is a non-accelerating situation. The horizontal velocity in this case, the original horizontal, is constant. The horizontal component of the projectile velocity is constant. So since this is a constant, non-accelerating situation, we can say velocity is distance over time. So distance is horizontal velocity times time, which we just calculated to be 1.96. The horizontal velocity is 7.79. So the range, or the horizontal displacement, is 7.79 meters per second times 1.96 seconds for a total of 15.3 meters.